Hey, how's it going, everybody? Welcome back. Today on Milanese Math, we're going to be continuing our series in Exponent. This is going to be part 2. And if you haven't watched part 1, well, you should probably go back. I'll try to remember and link that below because we're going to sort of build on that as we get into this discussion. So if you want to follow along with this worksheet, you can find it at the first link in the description below. Okay, so hopping right into it, we're going to treat this kind of like we did with part 1. And except this time, now we've got a situation where we have an exponent to an exponent, okay, or a power of a power. And a lot of math textbooks will just show you what the rule is, which might be all you're actually here for, but I think it's in this example, you really need to see where it comes from because it'll help you remember it. Okay, so let's say we have something like x squared to the third power, okay? So in this example, it's x to the second power, but then that whole thing serves as a base, and we're taking that whole thing to the third power. So if we were to write this out in separate terms, you could think of it as x squared times itself 3 times, right? Because it's x squared to the third power. So that probably makes sense to you. Now, if I wanted to expand this and break down each one of those x squareds, I guess technically I could break each one of those into an x times x, right? X squared is x times itself twice. So then there'd be another group of x times x and another group of x times x. Okay, so if I wanted to write that as one single term, x to the something power, all I have to do is count up my x's, and in this case, there are 6, okay? I'm doing this so that you can understand what the shortcut is. We're gonna give you the shortcut here in a second, bear with me. I just think that this will maybe help you remember what the shortcut is. Okay, let's do another one. X cubed to the second power, or x to the third to the second power. So we could write this as x to the third times itself twice, because it was to the second power. But then I could break down each one of those x cubed into x times x times x. And there'd be one more x times x times x. I can just feel you watching this getting frustrated with me. Why are you taking all the time to do this? I'm telling you, when we get to the end and you see the rule, hopefully you're gonna understand where this came from. Okay, so x to the 6th power, because altogether there are 6 x's. What about x to the 2nd power to the 4th power? Well, I could rewrite that as x squared 4 times. So fill that out with me. X squared and another one. Okay, so if I wanted to rewrite that and break down each one of those x squareds, I guess technically it could be x times x and do that 4 times. Okay, now if I were to write that as one term, that would be x to the 8th power, because if you count them all up, there are 8. We're almost done. Please don't hate me. We've got a few more of these to do, and then we'll talk about what the shortcut is or what the pattern is. So x to the 5th power to the 3rd power, that would be x to the 5th 3 times. Okay. Oh boy. All right. So if I was gonna break each one of those x to the 5th power down, that would be 5 x's. So a group of 5 x's 3 times. So here we go. Let's speed through this. 1, 2, 3, 4, 5, and then another group. 1, 2, 3, 4, 5, and another group. 1, 2, 3, 4, 5. Good Lord. Okay, how many x's are there altogether? If you counted all those up, there are x to the 15. It would be, there's 15 of them, so x to the 15th power. Obviously, we're not going to want to do this every time. We're almost done. One more. Here we go. X to the 3rd to the 3rd. So that would be x to the 3rd 3 times. Okay, and then if we broke down each one of those x cubes, it would be 3 x's, and another 3 x's, and another 3 x's. And if you were to count all of those up, you could call that x to the 9th power. Okay, good job. You did the whole table, and I'm proud of you. So the question is, what pattern do you notice? Because that takes a lot of time. You wouldn't want to do that every time you had a math problem. Look at the first column. A power of a power. And then how did we go from that to that last term? Well, if you haven't caught on already, there's 2 parts to it. First, you're gonna keep the base. What I mean by that, if you didn't watch our last video, we kind of identified those, but The base in this example is the x. That's the thing that is being multiplied by itself. But what are we doing with those exponents to get to the final answer? Well, in this case, we multiply the exponents. And I'll just run through that again, make sure you caught that. So like, for example, look back up here at our very first one, x squared to the third power. If you take a look at these 2 and 3, 2 times 3 makes 6, which is what's over here on the end. You could pick any one of those. How about the x to the fifth to the third power? 5 times 3 is 15. So if you have a power to a power, or the thing that you're taking an exponent to is an exponent itself, you can just keep the base and multiply the exponents. That was the hard part, was getting to where we understand what the rule is. Applying it is a little bit easier. So let's just take an example here. Y to the second, I'm on number 1, y to the second to the 8th power. Well, the rule says keep your base, which is y, multiply your exponents. 2 times 8 is 16. That's it, y to the 16th power. So you're just keeping your base, multiply your exponents. How about number 2? Well, it would be b to the 18th power, because I kept my base, which was b, and took 6 times 3, which was 18. Okay, now check out this. When we have one like number 3, that where the base is 5z squared, so the base has a coefficient. It has this 5 out in front. And when we do one like this, both the coefficient and the variable term get the power of 3. Well, let me show you what I mean. I'm going to draw an arrow here. This looks like I'm talking about the distributive property. This is not the distributive property. It just kind of looks like it. So another way to rewrite this would be 5 to the third power times z squared to the third power. Okay? So you just have to remember that if you have a coefficient, it also gets the exponent that's on the outside. So if I were to simplify this, that would be 125 z to the 6th power. Let me just make sure you understand where I got that. 5 to the third power is 5 times 5 times 5. That's where the 125 comes from. And then the z to the 6th power, well, if I have z to the second to the third, I can just multiply my exponents. 2 times 3 is 6. Okay? So once you sort of get the hang of that, you can kind of just apply that rule. Let's take a look at number 4. So I've got this exponent of 2, which is going to go to the 7 and the d to the 18th. So if you know your squares and you have those memorized, 7 squared is 49. And I'm going to call this d to the 36th power. How did I get a 36? Well, I used the rule. Keep the base, which was d, and then multiply your exponents. The 18 and 2, multiply 18 times 2, you get 36. Okay? The most common mistake I see is that students just forget to apply that exponent to the coefficient. So like a common wrong answer that I would see would be 7d to the 36, just because, or 14, because they want to do 7 times 2. But remember, that's 7 times itself twice. Okay, how about a couple more examples? Some of these are going to get a little bit tricky, but I just want you to be able to see some tough ones. So number 5, I've got x to the 4th times y to the 2nd, and the whole thing is to the 5th power. I'm going to draw these arrows just to help remind you that both of those terms are going to get the exponent of 5. So I'm going to do this all in one step. Hopefully this isn't going too fast for you. What would that first term look like? It's x to the 4th to the 5th. Well, keep your base, multiply your exponents. So 4 times 5 is 20. What about the y term? What would it look like? Well, it would be y to the 10th power, because 2 times 5 is 10. Okay? Once you start to get the hang of this, it's a little bit more straightforward. What about one like number 6, where you've got a term like a and a b and a c? Well, guess what? All 3 of those are going to get this exponent of 10. Okay, let's see if we can work through this. I'll go slowly, but I'm going to do it all in one step here. A to the 2nd power to the 10th power, I'm going to call that a to the 20th power, because 2 times 10 is 20. Now, technically, what exponent is here on this b? Well, technically, it's b to the 1st power. Okay, you don't have to write that in. Sometimes my students do, just to keep track of it. But in this case, it would be like saying 1 times 10, which is 10. So this will be b to the 10th power. And then finally, c to the 12th to the 10th power. Well, that would be 12 times 10. So this is going to be c to the 120th power. So a to the 20th, b to the 10th, c to the 120th. Okay? All right, here we go. Last one that we're gonna, I'm sorry, we have two more that we're gonna do together. Okay, so look at that whole expression and notice that outside the parentheses, there's a fourth power. Remember, everything on the inside is gonna get the fourth power. So the coefficient over here, that 2 is gonna get it. The g to the 5th is gonna get it. The 3rd is gonna get it. And the h to the 4th power is gonna get it. So let's walk through these one at a time. 2 to the 4th power, again, if you need to grab a calculator or something like that to help you out with this, you can. But 2 to the 4th power is 16. Now the g to the 5th power, 2 to the 4th power, is going to turn out as g to the 20th. And again, I just took 5 times 4, which is 20. Then how about 3 to the 4th power? So this is 3 times 3 times 3 times 3. That's going to be 81. And then finally, this will be h to the 16th power because I had h to the 4th, to the 4th power, keep the base, which is h, and then multiply your exponents. 4 times 4 is 16. Yikes. Okay, so it's not overly complex. It's just you have to take it one step at a time and don't let yourself get too carried away. So let's do one more example here. And this is actually going to combine this lesson from this video as well as the rule from the first exponent lesson that we did in the previous video. So let's just take a look at this r to the 4th power to the 3rd power. I'm going to call that r to the 12th power, right? Because you keep your base, multiply your exponents. So really this simplifies to r squared times r to the 12th. Well, if you remember from our previous video, when we have a situation like this, we're going to keep the base and add our exponents. So I would call that r to the 14th power. So that's why I'm doing a video series here, because the rules from the first video kind of match with the rules in this video, and sometimes you need to use both of them or all of them all in the same problem. And so we're breaking them down one at a time, but just be aware that some problems are going to require you to apply all of the rules of the exponents. So hopefully this video was helpful. If it was, consider subscribing to the channel. And as always, thanks for watching, and we'll catch you next time.